So I'm going to start with number 3, and I'm going to show you basically everything that we need to do and all the different options, or at least many of the options. So for number 3, this is the one where we had the vehicle miles traveled per household. These are measured in thousands, and we wanted to know at the 5% significance level, is there a difference between the Midwestern and the Southern households? Okay, so what I'm going to do is literally copy and paste the data. I'm going to call this Midwest. Okay, so copy, just to make sure that we got all 15 values. I think it's worthwhile just to make sure, that the length is 15. And also we're going to do the same for the South, so literally copy paste. So we're going to copy paste that data, make sure we got all the values there. We didn't leave any out, so we got 14. Okay, now this t.test function is just magic. It's perfect. T.test, what we're going to do is we're going to compare the Midwest data with the South data. We don't have to do anything special about computing the means, the standard deviations, right? So all that stuff that we did before, we don't really have to compute. I do want to point out, and I'll go through the documentation for this in just a second, but this is enough. The default settings for the t.test function is that your alternative hypothesis is a two-tailed hypothesis. So it's always going to assume that mu1 is not equal to mu2 is your kind of default alternative hypothesis. And then it also just automatically assumes that you want 5% significance until you tell it otherwise. One other feature that's going to be useful is that you can also indicate whether you're going to have equal standard deviations or not. Okay, so whether it's really a pooled t-test or an unpooled t-test. And again, it's going to assume that it's unpooled unless you say otherwise. Pooled t-tests are really rare because you have to know that both of your populations have the standard deviations that are equal, but you don't know what those standard deviations are, and you don't know anything about the population means. It's kind of a weird set of assumptions. So most of the time, it's going to be a non-pooled t-test, and if that's the case, all the defaults are set up. Type in t.test, it spits out this amazing array of information. Okay, so it gives you your t-value, which we said was negative 9.24. Our degrees of freedom was 26.344. So really, if you're going to do this, if it's a non-pooled t-test, you're supposed to round down. So your cutoff should really be just 26 degrees of freedom. This gives you your p-value, which tells you, so at the 5% significance, right, do we reject or not? It turned out we did not reject. Okay, we didn't have enough data to say that they were different. Okay, this gives basically everything else. This gives you a 95% confidence interval. This gives you the sample means of x and y. This does not give you sample standard deviations. That's about the only piece of data that it doesn't give you. But we don't really need to know what those are if the t.test function has everything kind of built in, right? The only reason why we needed to know the sample standard deviations were to run the t-test, so it doesn't have to actually spit out that value. That's not going to actually help us that much, which is why they don't include it in the output. Okay, and that's it. That's the entire test. T.test. We took our two data sets, Midwest and South, and it gave us everything that we wanted. Okay, so that was the this is the one where we computed our test statistic to be negative 9.240, and then our cutoff values, our critical values. If we're talking about a 5% significance level, what we're going to do is we're going to pick we have to take the 0.05 and cut it in half, so that's 0.025. And then I just like to do the positive one, 0.975. We have 26 degrees of freedom because that's what we get from our t.test function. So we get 26 degrees of freedom, and there's the 2.0555 value that we were talking about as our test statistic. Okay, so there our critical value. So that's our critical value for 26 degrees of freedom. And I just want to point out that if you use the 0.025, you'll get the same thing, just negative. So again, because of the symmetry of the t-distribution, that's how that works. So that's how we do number 3 with R. Okay. If for number 3, instead of 5% significance, if I wanted to do 1% significance, what we would do is we would do the same thing. Let me actually show you the documentation here. So if you do help and then t.test, not t comma test, come on, help t.test. Okay, it's going to open up this documentation. It gives you all of the different values that you'd need. Okay, so this confidence level is going to change depending on what your significance level is. So if we had a 5% significance level, that's going to assume that's the default, so that means a 95% confidence level. If you want to change whether it's two-tailed or left-tailed or right-tailed, that changes the alternative. So you would say two-dot-sided or less or greater. I'll show you how all that works. And then the other thing that's going to be useful for us is this var.equal. So if it's going to by default assume that the variances, are not equal. That's the non-pooled t-test. If you were to type that these are equal, then this is going to run the pooled t-test. Okay, so that's the value there. The final thing is that you can actually write y equals null, and this will actually run a t-test for one population mean with all these values. So you can also use this formula to talk about one population means, okay, which I'll go back and I'll do an example of in a second. All right, so next let's talk about number 4. So we had perished and survived. Okay, so we have perished. That was our data. So I'm just going to write perished. Oops. I don't know why I copied the name and not the data points. There we go. So it's perished. And again, I just like to double check. Yeah, we have 24 data points there, which is what we should. We have 24 there. And then in the survived group, we're going to have a few more data points. So the survived group is going to be that data set. Let's make sure that we got all 35 values, and we did. And then we're going to run the t-test. It's going to be the non-pooled t-test with the data perished and survived. And again, it spits out this amazing array of information. It gives us our test statistic, our degrees of freedom, our p-value, 95% confidence interval, and the means of each of the data sets. Okay, so that's how that works. Since our p-value was larger than 0.05, we did not reject. Okay, so we did not reject the null hypothesis for number 4. Okay, and that's really all we need to do. Okay, that's how we run the t-test. That's how we do all these chapter 10 problems. The last thing I want to point out, again, if I wanted to do a t-test where, let's say I wanted to know, I know the p-value, so I'm just going to cheat slightly, but let's say I wanted to know not at the 5% significance, but maybe 10% significance. So t.test perished, survived, those are our data points. I would change the confidence level to 90, okay, so that we have a 10% significance. And if we were to do that, we get basically the same data, okay, but now we have a 90% confidence interval, okay, rather than a 95% confidence interval. And again, there's a few different ways to interpret this, but because our p-value is now less than 0.10, we would reject the null hypothesis if we were running a 10% significance test. Okay, so really that's the only thing that changes. The p-value is going to tell you what significance level do you reject or not reject. Okay, so that's the number 4. All right. Number 5, what we had was Charles Darwin studying his plants, whether they were cross-fertilized or self-fertilized, and he looked at the differences in heights. And so again, let's copy this data. I'm going to call these differences. And for some reason, R doesn't like the minuses that show up in the PDF, so I've got to change those to minus. And those are going to be our differences. And so let's look at the length of this set. Let's make sure we get the right length. Yeah, 15 differences. And then what we're going to do is run a t-test for the differences. It's that easy. Okay, so we run a t.test for the differences. You can run a t.test for differences. You could also, if you write y equals null, it's going to give you the same values. It's actually not going to be anything new or different, right? But what it does is it tells you the mean of your sample. It tells you a 95% confidence interval, which is the thing that's the part C that I asked. It tells you your p-value, your degrees of freedom, your test statistic, your alternative hypothesis, and so on. Okay, so all of that is there. Okay, so that's the t.test function. All right.